Hello, everyone. A very warm welcome to all of you. So we will just begin in 2 minutes. Thank you for joining. A very good evening to all of you. Thank you for joining us for the masterclass on Demystifying AI by Dr. Sailesh Kumar, who is the Chief Data Scientist at Reliance Jio. In today's masterclass, Dr. Sailesh will explore how AI is transforming the world we live in by understanding AI at an intuitive, philosophical, process, and application perspective. I hope my screen is visible to all of you. Dr. Sailesh is currently the Chief Data Scientist at the Center of Excellence in AI/ML at Reliance Jio. He has published over 20 international papers and books and chapters and holds more than 20 patents in AI/ML. Dr. Sailesh was formerly the president of Ola Cabs, where he worked on several computer science, machine learning, artificial intelligence, and optimization issues in fleet management. He was also the chief scientist and co-founder of Third Leap, an edtech startup that uses AI to create personalized math guides. Prior to this, Dr. Kumar also worked at Google on a variety of products at Google involving information retrieval, enterprise search, legal e-discovery, natural language understanding, computer vision, knowledge graph mining, conversation modeling, and deep learning on text and vision. Thank you so much for joining us. Over to you.
Thank you, and it's a pleasure to be here. Let me share my screen. Okay. All right. Can you see now?
Yes, sir.
Okay. All right. Good evening, everyone. And it's a pleasure to be here. It's an honor for me to be talking to you today as both Chief Data Scientist at Reliance and also, sort of program chair / mentor of the AIDS program at Geo Institute. So what I'm going to do is today kind of demystify AI, right? In a way, a lot of buzz is around. A lot of people have a different idea of what it is. And some, and obviously it's an amazing technology. We all want to learn what it is, but we want to learn it in multiple ways, right? Different perspectives on AI. So we get to see what the full spectrum of AI is. So today I'm going to give you multiple perspectives on AI. Some philosophical, what is thinking, what is intelligence, and some all the way to how to apply AI to businesses. Is there a systematic process of it? And what are the different tools that are available in AI and some of the applications that you can think about, right? So let's start. Very recently, I think a few years ago, Sundar Pichai talked about AI like this, and he said AI is probably the most important thing humanity has ever worked on. Now, just think about what he's saying, right? Humanity has worked on many things, including inventing the wheel, discovering fire, and all the way to the internet, going to Mars now, autonomous vehicles, chat GPT, and all that. And all that is, some of this is using AI. But with all of that we have done, Sundar is saying that AI is the most important thing humanity has ever worked on. And, really, if you think about what he's saying, I think the last 20 years has seen an amazing adoption of AI in a few verticals, right? So we have built great search engines, we have built great recommendation engines, we have built great entertainment systems with recommendations and all of that. But we've done bits and pieces here and there very well. And we have proven that this works, right? We know that this works. We know that it can really, disrupt the way we think about how we, order food, how we order, retail, how do we do search, how do we do Ola, Uber. So we have really, put a lot of effort in AI-fying a lot of the services that we work on. But the next 20 years is going to be an even more amazing journey for AI. And that's why this is a very exciting time. Back when 20 years ago, we started learning AI, it was sort of something in the lab. We didn't have enough compute, enough data. But today it is a proven technology and everybody's kind of going through the same digital transformation 2.0 that we went 20, 30 years ago when we went through an IT transformation, right? From manual to automatic. And now we are going from automatic to intelligence. So we are going to use that as a context to understand what is AI and how do we get there. All right, so let's talk about AI not as an isolated technology, but really if you look at the world we live in today, we have some amazing technologies that are in our midst, right? And uh, 30 years ago also we had AI, but today we have cloud, we have connectivity, we have devices, we have IoT, we have the internet, we have 3D printing, we have AR, VR, we have blockchain. So really this is a very amazing time to have so many technologies around us. And now we can really combine all of them to create amazing products and services, right? And the next 20 years is going to see this integration of technology, convergence of technology to build products. And that is the first big thing that will happen. The second big thing that will happen is we are going to now move towards social transformation with AI, which means how do we disrupt education? How do we disrupt healthcare? How do we disrupt agriculture, right? How do we build smart cities? So now that we know how to build search engines and Amazons and Netflixes, we are going to now move towards core social services, and they will become much better because of AI. And that is the unfinished promise of AI. And that is what all of us should think about, and that's what Geo Institute is thinking about every day. And that's what my team is thinking about every day. How do we build AI for the social use cases as much as we have built for industrial use cases, which is continuing to happen. Yeah. All right. So now let's think about what is a great product. If I ask people what is a great product, we all have a favorite product, right? And some of us like products like phones and iPhones and iPads and devices. Some of us like products like Alexas and Siris and Google Voice and all of that. Some of us like products like Swiggy and Zomato and food delivery apps. We also like products like Google Search, Google Maps, YouTube, Twitter, LinkedIn, and all of that, right? So these are the great products that we are surrounded with. And the idea of product has evolved, right? Earlier, if 20 years ago I had asked this question, what's a great product? People would say, a color TV is a great product, an AC is a great product, a Porsche car is a great product. But today, the idea of product is very different. And 5 years from now, the idea of product will be completely different. And we will talk about smart city as a product, a connected car ecosystem as a product, and so on and so forth, right? So the idea of what is a product is evolving. But the core principles of what makes a great product is still the same. So let me talk about the 5 I's that make a great product. So the first I is the infrastructure. And what we have learned in the last 20 years is that we don't need to build products for the PC, but for the planet, right? And every product that you can think about, all the products we just talked about, they all scale without any inhibition. They scale, right? Google does 5 billion queries a day, no problem, right? Amazon delivers 50 million orders a day, no problem, right? Ola, Uber do hundreds of thousands of cab rides a day in a city, No problem, right? They all scale. So the idea is these are all very, very scalable products. And when we think about purely physical products like cars, iPhones, these are physical products. Scale means something different, which means how many can I manufacture in a day? How many can I distribute across the world? So that is purely physical products. The word infrastructure means something else, right? The road infrastructure, the manufacturing units, the distribution channels, that is infrastructure in a physical product. Now, let's look at the other type of product, which is purely digital products. So if I look at YouTube, Netflix, Google Maps, these are purely digital products. There is nothing physical about them, right? It's an app, you use it, you're done. So these are what we call purely digital products, and they can scale infinitely with the cloud infrastructure, right? So physical products can only scale with the resources that we have. Digital products can scale with cloud infinitely. And now we are living in a digital physical world where we have digital products driving physical activity. So for example, Amazon, Flipkart are a digital physical product. Zomato, Swiggy is a digital physical product. You do certain things digitally and certain things must happen physically for a complete experience. Ola, Uber is a digital physical product. So when we think about infrastructure in a digital physical product, we are limited by the physical, right? And that's why, push towards autonomous vehicle and all of that, so we can scale that also. So we understand the first I is the infrastructure. The second I is what we call the interface, right? So today you're seeing a migration of how products are becoming more and more beautiful, right? Every now and then, the next version of your app is more beautiful than the previous version, right? It is more easy to use, more intuitive, more speech enabled, uh, and all of that, right? So the interfaces are going to become more and more human-like. And that's why technologies like computer vision, speech, NLP are going to become more and more important, because we want to be able to talk to our machines, our products and apps, the way we talk to each other, right? So that interface is going to become more human-like. The third I is what we call the intelligence. So it's not enough to build a great, scalable, and a beautiful product. It is very important to make sure the product is continuously learning and improving over time. And that is why AI is now playing a very central role in product thinking, right? Earlier, we used to think about customer needs, market fit, front end, use design thinking and all that. Now, AI is an integral part of every product. A product is incomplete without intelligence. So that is the role AI is playing. So Google Map is intelligent in its own way, and Ola Uber is intelligent in its own way, and YouTube is intelligent in its own way, right? So every product has these three I's. This is what I call the MVP of today. When you think about the product, at least they should have three I's, right? The next two I's we'll talk about. The next I is instantaneous. So now we are in a world of instantaneous, right? Google search comes to you in 300 milliseconds. YouTube gets downloaded right away. Netflix gets downloaded right away. Medicines get delivered quickly. Pizza gets delivered in 30 minutes. So now everybody's processing, promising instantaneous everything, right? Loans are getting done very quickly, 3-minute loan, 5-minute loan. So everything is now quick. And even the video consumption has become shorts, right? Short videos. So instantaneous, short, all that is happening is the next I. And the final I is what I call integrated products. And this is where the next 20 years we are going to spend, which is how do I take a Tesla car as a great product, Google Map as a great product, the connected car ecosystem of the city as a great product, insurance, auto, mechanics, manufacturing units, gas stations, traffic infrastructure, and how do I integrate all of this? The car is integrated with the GPS, with the Google Maps, with the traffic signal intelligence, with your insurance company. That becomes a connected car ecosystem, right? Or how do we not see our energy consumption, our air pollution, our carbon footprint, our road network, our telecom network, our electricity grid? How do we integrate all that into a smart city, right? And safety and security. So the next future of where we are heading in the next 20 years is we know how to build individual products well. We are now in the age of integration. How do we integrate multiple products to give a very seamless experience? And you're going to see the birth of integration every here and there, right? Alexa is integrating multiple services, for example, right? So how do we integrate products? All right. So now let me switch gears. Let me talk a little bit about how do we prepare for that world where we are heading, right? We are heading towards a world of amazing integrated products where, the overall healthcare of a country is a single product, right? With its all supply chain of medicines and all that. Entire agriculture of a country is a single product with all the advisories and the satellite data and all of that. How do we change our idea of what is a data scientist? What role are we going to play in that world? And that is how we have designed this course. That is why how I teach my courses in ISP and everywhere to really think about the core skill of a data scientist, right? So we do need to learn a lot of math, stats, and optimization. It's a very foundational skill. We need to learn a lot of machine learning algorithms on one side. We need to also know how to deal with very, very large volumes of data because we have become a data civilization. And how do we incorporate domain knowledge into what we do? So these are the 4 foundation skills. And the 5th skill, that is the center, is really the skill of formulation. How do you convert a business problem into an AI architecture? And that skill is what I think is missing. We know how to do domain understanding because we have domain experts in every domain. We also know how to handle data, how to store data, how to build models. But who is the layer between? That is missing, which is the people who can connect business problems to an AI architecture. And that is what I call the art of formulation, right? So that is the ultimate skill. So, a carpenter is not a great carpenter just because he knows how to use a hammer or a chisel or an axe. He becomes a great carpenter when he knows how to build a chair or how to build a teak wood door or something else, right? So how do you connect the tools that you have with the end goal that we have to do, which is how do you solve business problems, right? Or operations problem or customer problems. So how do we deal with that? And how do we use the tools to do it? Who is going to create that is the architect, AI architect. So in my mind, the word data scientist will morph into the word AI architect. And that's the person we really need. Building models is automated now, right? So we don't really need that skill of building models. We need a real skill, which is how do you convert a business problem into an AI architecture? All right. And really, if you think about science, right, all science is really about the art of formulation. The great scientist who formulated the formulas of laws of motion, laws of gravity, laws of thermodynamics, they were the real scientists, right? Everybody else is just an engineer. So really, formulation is the key skill in all sciences, and it remains the key skill in data science as well. Yeah. All right, so now I'm going to show you a small clip. This is from Star Trek. This is one of my favorite clips I show to all the students. And this really puts things in perspective on what is data science, what is science in general, and what kind of attitude we need to have to learn data science. Right? So let's watch this. Hopefully audio will work.
What do your sensors indicate?
Nothing, sir.
Mr. Data, you must mean that it's empty of matter. There's always some energy form at work.
Sir, our sensors are showing this to be the absence of everything. It is a void without matter or energy of any kind.
Yet this hole has a form. Data has height, width.
Perhaps. Perhaps not, sir.
It's hardly a scientific observation, Commander.
Captain, the most elementary and valuable statement in science, the beginning of wisdom is, I do not know. I do not know what that is, sir.
So, in all sciences, right, the attitude, if you look at the history of science, when Newton saw the apple falling, the first question was, I do not know why the apple is falling, and I do not know why the moon is not falling, right? If everything was supposed to fall. And that is how the journey of science begins, right? It begins with a question. It begins with ignorance. And that is how data science journey also begins. It begins with ignorance, right? It starts with, and I've experienced this every time I change my vertical from finance industry to search industry to retail industry to Ola Uber industry to now refineries and all the different verticals I worked in. I start with, I do not know what the domain is. Let me understand the domain. I do not know what the data is trying to tell me. Let me dig into the data. And then I do not know how to formulate the whole thing. So I will think about it and start to create an architecture. So these three skills of learning domain, learning data skills, and learning how to formulate is kind of the blend that we need to figure this out. All right. So now with that context, let me talk about AI from a technology perspective, right? So what is technology and what kind of technology AI is? AI is just another technology, right? But if I look at what is technology, we all would agree to a very basic definition of technology, right? Which is technology is nothing but an extension of who we are, right? So if we don't know how to lift heavy things with our hands, we created the lever, the crane, and all that, right? If we don't know how to run very fast, we created the wheel and the car and the super fast trains, right? If we don't know how to fly, we created aeroplanes and all that. If we don't know how to speak loudly, we created microphones. So basically, if we cannot see very far, we created the telescope or microscope. So the idea is technology is nothing but our ability to extend our own abilities to do things, whether it is perception of the world or actions in the world. We are extending ourselves, right? Now, with that basic definition of technology, if you want to understand what is AI, AI is really an extension of one of the most unique gifts that we have been given, which is our sense of intelligence, right? So if you think about what makes us different than all the other species on the planet, it's all about our intelligence. So today we are going to wonder what is intelligence and how do we institutionalize intelligence in these different verticals, right? Now, a lot of people ask me, why is it needed? Why should we do intelligence with machines? Why can't humans remain unique and intelligent? Why do we have to copy human intelligence into machines and have a chat GPT write a news article instead of a human journalist write a news article? Or whatever, right? Why do we need a human AI version of an AI doctor who can diagnose diseases? Why not a human doctor? Why is not that good enough, right? So now think about it, right? So how does a human learn over a lifetime of experience? Let's say a doctor learns over a lifetime of experience by treating hundreds of patients every day, how to do, diagnosis better, how to treat patients better. Each doctor learns on their own. They learn through the school and then they learn through experience and they're continuously learning. But their learning is only shared with other doctors in a very limited way, right? Conferences, talk to each other, mentor each other. But now imagine if an AI doctor can treat 1 million patients every second, how much data will it have to learn from? Now that can replace, all the cases that it is seeing, all kinds of combination of symptoms it is seeing, and it can really learn a very amazing diagnosis system that an individual doctor will take many, many years to learn over a period of time, right? Let's take another example. Today, if we are using humans to read all the papers, come up with the next thing to do drug discovery or cure for this disease or that disease, why do pharma companies take decades to build a new medicine? Because there's a lot of research that has to happen. A lot of people get involved. But now imagine if AI could read all the medical documents in the world today and 100 years from now, if all of that knowledge has been loaded up in a cloud environment and all the reasoning you could do on that knowledge, all the dots you could connect, it is not possible by a human to read that much, to hold that much in memory, to connect all that dot, to think about what to do next. But for an AI system, it is just a 5-minute job, right? So the power of human intelligence, when magnified to the level of cloud, And with all this data that a single human cannot consume in a lifetime, that magic that it can create is just mind-boggling. And that's why people like Sundar and everybody is so excited about this technology, that we can really do wonderful things that even with 100 people as a collective, we cannot do what AI can do in a single day, right? And that's what we are seeing, right? So that is the potential. Now the question is, how do we apply that to social transformation of the world? How can we make our social infrastructure better, right? That's the promise that we are all heading towards, right? So now when we say technology is evolving, what we mean by is all these things are evolving, right? Our tools are evolving, computing is evolving, our interfaces, our idea of intelligence is evolving, our idea of data is evolving, and even our idea of a product is evolving. Our AI thinking has to keep up with all that, and our data science skill set that we need is also evolving, right? So all these things are evolving. So let's look at that in a little bit of perspective, right? So if I say our tools are evolving, right? So technology is not something we started creating 5 years ago, right? Technology mankind has been creating since the birth of human civilization. We could not, hunt with our bare hands, so we created axes and bows and arrows. Then came the industrial revolution. We wanted to do, deep mining of, resources, go underground to find oil. We had to do so many things. So industrial revolution came and we mechanized everything, right? And modern industrial revolution is all about robotic automation, whether it's a warehouse of Amazon or a car manufacturing unit of Toyota, it's all robotized, right? So the idea of tools has evolved. Tools are like our hands. This is an extension of our hands, and see where we have extended our hands and brains together to create robotic tools, right? So tools have evolved. Sensors have evolved. If you think about the first sensor, let's say Galileo's telescope, which could only see up to the sun and figure out what the sunspots are all about, today we can extend the same sensor to say we can now look at the far reaches of the galaxy. At the time of the Big Bang, we can actually get signals, radio signals from there. We can also now send our sensors to other places, to the end of the solar system, to Mars and to Moon, right? So these sensors have evolved all the way. Now, this is a very important slide for AI people, right? If you think about the way we perceive the world, the way we understand the world, the only way we understand the world is through the sensors that we have. Humans have 5 senses, and we perceive the world through those 5 senses. If one of the senses is not working, your worldview is limited. And then language is the 6th sense, if you will. So now through these senses, we are understanding the world continuously, right? So this is one idea of sensor. Sensor as in human sensors. Now let's look at the second idea of sensors, which is, if you look at all these sensors, right? If you look at any domain, agriculture domain has hundreds of sensors, right? Soil IoT sensors, remote sensing, weather sensors. So that is a world of sensors. If you look at manufacturing industry, it is capturing all kinds of, sensors, instrumentation data coming out of every machinery, right? Vision sensors, signal sensors and all that, right? If you look at medical world, an amazing amount of sensors, right? All the way from a stethoscope to a COVID test, to a thermometer, to an X-ray, to a blood test, everything is a sensor. So the medical world is full of sensors, right? So now we understand that every, sensor that we have created across different verticals, we have sensors, right? Your mobile phone has 5 different sensors. Aeroplanes have sensors, storing all that data in the black box. So we are now a sensor civilization. Now let me extend this idea to one more step. If you think about what Google search does, or what Amazon Ola does, or what telecom networks do, they also collect data, right? So if you think about what is a sensor is anything that collects data is a sensor. Then, Paytm is a sensor, GPay is a sensor, UPI is a sensor, telecom networks are a sensor, every retail is a sensor, a transaction is collected, every bank is a sensor, So now not only sensors are sensors, but every application, every service, every product you use is also a sensor, right? And now, your perspective on what is a sensor has to evolve and say, do I build in a world of AI? Do I build a product first or do I build a sensor first? So in a way, we are building a sensor now, and we are surrounded by sensors. And because we are a sensor civilization, we are now a data civilization. And because we are a data civilization, we have to become an AI civilization, right? So you see the logical progression of where we are going. Yeah. Compute is evolving, right? Back in the day, most of us were not born then. Compute was all about, a room full of wires and you had to plug them in. There was something called a punch card, and I was too young to know that. But then came a PC revolution where everybody had a PC at home, and we grew up with a PC at home, right? And today we have a cloud revolution. And the next 5 years, we are going to see a quantum revolution, right? So the fourth picture on this slide is going to be a quantum computer. So you see how computing is evolving in front of our eyes, and what cloud does to PC market is exactly what Ola Uber does to a private car ownership market, right? So the idea is, if you have your own PC, you're going to use it only so much time a day. You can only store so much data. It can have only so much RAM. It can process only so much CPU speed, right? But if you rely on a cloud, just to say, okay, while I need the cloud, I'm going to use the cloud, and then I'm going to let it go, right? So when I'm checking my Gmail, watching my YouTube, doing my LinkedIn, watching my Netflix, I need the cloud for that period of time. Those resources are allocated to me, and then I let go of it. Others can use it. So it's a shared resource environment, which makes a lot more sense from an economics point of view, right? And that's why the devices we use, our mobile phones, our laptops, are not really computers now. They are connectors to the real computers, which are the cloud computers, right? So we need to change our idea of what is a computer now, right? The idea of data is evolving, right? Back when we were studying data science, the term was not even coined. Data was all about an Excel spreadsheet with rows and columns. But now data is everything, right? Whether you do a gene sequencing of a new child that is born, or a COVID virus, or a plant, all this genomics data that is coming, right? All the satellites that are roaming around the earth, hundreds of them, probably thousands of them, they are collecting data of all kinds, right? What's going on in the oceans, over the surface, under the surface, in the atmosphere, everywhere. So satellites are collecting tremendous amount of data. Every financial transaction, credit card transaction that happens, just imagine the number of transactions that happen per minute in the whole world. It's just amazing how many, right? So it's a transaction data. Every time we do groceries, it's a transaction data. Every time we buy or sell a stock, it's a transaction data. Every time somebody writes a book, reads a book, likes a book, whatever it is, it's a transaction, right? It's a text data that is generated. And then came the internet, which completely changed the way we think about data, right? And every click, every post, every like, every share, everything became data. Every connection on Facebook, every connection on LinkedIn, every connection you did not take that was suggested is also data. Every YouTube click that you did and watched the video is also data. So the idea of data has evolved tremendously in the last 20 years. It's fascinating how data has changed the way, the diversity of it is just mind-boggling. And we are not done yet, right? Now the next level of data has come, the IoT data. So now if you think about how does Ola, Uber work, so every time somebody takes a ride, that is what we call a transaction data, right? You open the app, you book the ride, you pay, you finish the ride, you give a rating, is one transaction. And there are thousands of transactions happening every hour. So that is transaction data. Every bank transaction, every money transaction, every food order is a transaction. But how does Swiggy, how does Uber, how do Zomato, how do they know where their people are at any given time, where the cabs are at any given time? And that is what So there is a ping that goes to the Ola Uber server every 6 seconds that says, this is the car ID, this is the lat long, this is the timestamp, this is the current status of the car. Is it in ride? Is it free? And all that. That ping that comes from every car every 6 seconds is an IoT data. So now companies use both kinds of data to say, this is the overall data that I need, right? So now there is no such thing as I like this type of data, you like that kind of data. It's not like that. Everything is out there. We need to develop a rich understanding of the beautiful types of data out there. How are they used in different industries? So we have a very rich, 3-4 courses just on data, understanding data from different perspectives, different nuances in data, data visualization, big data thinking. All this is going to build a very strong foundation on how to think about data in general. Data storage, data access, data security, data governance. All this is an amazing area to just think about, right? We have a very rich data civilization now. And, I think somebody said that we are collecting now as much data in a single day that we had collected through the rest of the human civilization until that time. And this was set in 2013 or 2012. So now imagine, where are we? Okay. Now, the next thing that is evolving in technology is what we call the interfaces, right? So the idea is, we started with a very gory touch, feel, menu kind of an interface, which was very unnatural. It was very beautiful, but still unnatural. Now imagine you can just tell your phone, hey, I need to go home. Can you book a ride? And that's where we are heading now, right? So the world is heading towards personalized assistants with very natural interfaces. And this is very much required because if you think about the 70% of India, the Bharat, which is not yet connected to the digital bandwagon, which is not experiencing the benefits of AI and technology yet, is because of interface, right? If you give a farmer a very complex interface written in English, he cannot do much. But if you give him a single button where he can say, hey, my kid is not well, what to do in his local language, or where he can say, I need to know what plant to grow, or he can say, tell me, which fertilizer to apply and how much, or should I water my plant? He can ask any kind of question in any language for any use case. Can we answer that, right? Are we speech enabled in all 22 Indian languages? Are we able to understand all accents and dialects, right? Are we able to convert them to all possible use cases in agriculture, healthcare, education, commerce, anything that they want to do? Have we built a universal personal assistant for the last mile? If we have not done that, we have 20 years in front of us to get that done. And that is what we are trying to get to, which is how do we bring the benefits of AI through a beautiful, simple interface and a complicated thing that can be done end to end, an integrated system on the back end. That imagine a farmer just takes a photo of his crop and 3 hours later, he gets exactly the right pesticide he needs. That is the level of potential of AI. And this cannot happen unless we integrate all aspects, right? His ability to take a photo or speak, convert it into understanding what he's saying, converting into, actions, predictions, then optimization, supply chain. Unless we start building integrated systems end to end, we are not going to deliver this promise. And that is what, Reliance Jio, many people, Google's, they are all now looking forward to building this end-to-end system, right? So that is the true potential of AI, and which will transform a lot of things. So that's why it's a very exciting area, and we are very excited about the course that we are working on and having you on there, right? Now, the next thing that has happened is decisions have evolved. So if I have to explain to my grandmother, what does AI do? Really, AI helps us make better decisions. So on the ground, what does that mean? It means that now, instead of a broadcast decision, we can make a personalized decision, right? A broadcast decision is, hey, same education for all children in that class across the country at the same pace. Everybody getting the same exam, same homework, same teacher teaching the same course. Is a broadcast decision. What is personalized education? Is it even possible? So Byju's and Khan Academies are also broadcast decision. We have not yet personalized education at all. We are still digitizing it. We have not personalized it, right? Same thing. If Krishi Darshan program is what a farmer watches every day, that's a generic advisory. It's a broadcast. Can we make it personalized? And every morning, every farmer, based on their satellite data, their IoT data, their weather in that area, what they are growing, what is the stage of the crop, can I give a very customized advisory to every single farmer in the country? That is the promise. How do we get there? Yeah. Second, batch to real-time decisions. Today, we make a lot of decisions on batch, right? Diwali sale, Christmas sale, this sale, that sale. But can we make real-time decisions that say, look, I'm seeing that your Fitbit score is going up and down. You need to see a cardiologist immediately, right? Or if Ola, Uber, driver was sleeping, you missed a ride to the airport, immediately that event should trigger another event that says, I'll give you 3 rides free, because we missed your flight. So how do we make real-time decisions? Like in retail, you can say, hey, somebody bought a printer. Can I give him a cartridge coupon 3 months later? And that's a real-time decision, right? Based on a previous event, not because it's a Monday sale. You see the big difference between thinking about time. How do we make proactive decisions instead of reactive decisions? So today what we do, we have a bad health event, then we react to it. We have a farmer, not getting his crops enough, failed, then we react to it, right? A child fails an exam, then we react to it. But in the world of AI, we can actually predict everything. So how do we now go from reactive to proactive decision making? Before something bad happens, can I intervene? Now it is possible. Imagine what it will do to healthcare, to agriculture, to education. We are making proactive decisions, right? We have not done it. Therefore, we are now facing climate change and all that. This is the result of that, the world that we have created. We have been very reactive, right? Even climate change, we have been reactive, right? Then tactical to strategic decisions. How do we go from improving my current objective function to my long-term objective function, right? So if a farmer wants to improve the current crop, he will put all the fertilizer, pesticide on that. But what happens to the long-term health of the soil? And that's what is happening in many parts of the country where farmers are using a lot of chemicals. They are getting good yield now, but they're destroying their future by creating a bad soil. And that's what the soil movement is all about. So how do we balance tactical and strategic decision making? So these 4 dimensions of decision making are very critical. And we need to think how AI can actually transform the way we make decisions, right? Decisions have always been made, right? Banking decision, who to give loan, has always been made for the last 1,000 years. But now the way it is made is different. So really AI is helping us transform the way we make decisions, right? And that is the power that we have. Now, let's talk about evolution of intelligence itself, right? So a lot of companies I talk to a lot of startups, a lot of big companies, worked in many, many different verticals. And, now we are working at a national level, what AI is doing for India, all of that, right? So at all levels, we are looking at AI. So there's a systematic journey that everybody follows. So what is that journey? So you start with infrastructure, right? You build your road network, you build your, search and crawlers and indexer in Google, you onboard all your drivers and put all the apps in place, you build the infrastructure. Then you automate all of that, right? You put rule-based systems that say, if this, then that, if this, then that, you automate, and that's how you get scale. And you get consistent actions at scale. And now infrastructure along with automation happens. As a result of automation, we start collecting data, right? And the first use case of data was not data science. The person who started collecting data was a software engineer. He didn't even know that 15, 20 years from now, data science will come. So the first use case of data was debugging, just to collect the logs to see if something goes wrong. Then I need a log. So we started collecting data for a very different reason. The second use case of data was regulations. So now the legal system caught up with the technical progress, and they said, no, you have to store the data for some time. You have to generate these reports to say how good your telecom network is doing, how much energy consumption is happening, how much taxes have been collected last year. So now that became the second reason for data collection, to generate lots of reports. And now in the last 5 to 10 years to the next 30, 40 years, we are in the next mode of data, which is data to AI. So today we call it, all industries are now very data rich, right? We have a lot of data. Every bank is data rich, every insurance company, every hospital, right? Every government department, every area is very, very data rich. Now the question is, how do we go from being data rich to AI first? And that is the journey that everybody is taking. This is the promise of the next 30, 40 years. And we need a lot of help here, right? A lot of people across a lot of verticals will transform different verticals from being data rich to AI first verticals, right? And everybody is looking forward to that promise, right? Now, how do companies do this AI transformation? So they start with what we call business intelligence, which is simple reporting of numbers this way, that way, and all that. But this is actually a detour. Reporting the past is not AI, right? It is not going to help us the way we think AI can help us. So reporting the past is just giving us confidence that yes, we are collecting a lot of data. We can summarize it in many ways. But when I talk to people and say, what do you do in AI? And they say, we generate a lot of reports. Then I ask them, who reads them? And how do you consume those reports and do anything? And if it doesn't do anything, if a report doesn't transform your business process, if it doesn't improve your efficiency of operations, if it doesn't improve your customer experience, then it's a useless report. It's sitting as another pretty picture on your desktop, right? So the idea is reporting the past is a very limited idea of what AI can do. So what we need is we need to predict the future. We need to predict whether a customer will churn, whether a part in a manufacturing unit will fail, whether the economy will tank, whether the house price will go up, whether the next war is coming, whether the next extreme weather will happen. We need to be able to predict things. Prediction is how intelligent systems work, right? And we should be able to predict whether somebody is going to have a heart attack or a cancer. Can we predict that? Or Parkinson's? So we are supposed to go to a predictive level of thinking, because that's when we can intervene, right? And prediction is how we drive a car also, right? We predict all the time. What will happen if I do this and all that, right? So prediction is the first next level of intelligence. Now, prediction also is not enough. If I can predict and say, this is the customer who is churning, or you are going to have a heart attack in the next 6 years. If I can only predict and not intervene, it's a useless prediction. So the next thing is data science, which is, can you act on those predictions, right? To create a different future, right? So the idea is, what can I do about it is the next question. So what has happened in the past? What is about to happen? What can I do about it? These are the three fundamental questions that drive all decisions in all industries. That's how simple AI is. I promise to demystify AI. This is how simple it is. And then instead of saying, what can I do today? Can I also think about all possible futures and say, if I do this, what will happen? If I do that, what will happen? Can I actually simulate multiple futures and then take the best action? And that is when AI becomes a strategic decision-making tool, not just a tactical decision-making tool, right? So this is kind of the journey that most companies are taking. They're building a very strong foundation on data. Now they are saying we know how to report every metric. Now they're building prediction systems. And now they're starting to drive decisions directly from data, right, through a process. So that is the journey we all are there. All right, so let me now shift gears and talk a little bit about the philosophy of AI, right? What it is fundamentally. Why one class of people get excited about AI is to really learn what AI is because it's a fascinating thing. The brain is asking what a brain is. Just think about what I just said, right? Our brain is asking what the brain is. That is the recursive question that we are trying to answer in AI, right? So if I think about what is intelligence, right? And a lot of people will give a lot of different answers around, intelligence is the ability to solve problems, to learn from mistakes, to understand stuff, to, act in a new situation, to adapt. These are all great answers of what is intelligence, right? So in my mind, I have 5 layers of intelligence. So the first layer is the ability to learn, right? So we learn how to walk, how to talk, how to understand poetry, how to understand languages, how to understand science. So we are learning everything, right? So learning to look at the world around us and learn from it, understand the patterns and all that. Then learn causality, for example. Then the second thing is understanding. Understanding is very different. Learning is very different. Understanding is, how do you understand language? How do you understand speech? How do you understand images and videos? How do you understand a joke? How do you understand a gene sequence, right? How do you understand what is going on in a security camera? So how do you understand behavior of people or all these things? Understanding. Converting a low-level data into a high-level semantics is understanding. Then comes thinking. Thinking is a completely different skill in intelligence, right? How do I say, what should I do now? Then what should I do? Then what should I do, right? So Google Maps is like a thinking. Solving a math problem through multiple steps is thinking. Playing a game of chess is thinking. Having a conversation is also thinking, right? Whenever a sequence of actions are involved and you're trying to optimize a sequence of actions, that is like thinking. The next form of intelligence is creativity. And now, if you're aware what's going on in the world of AI today, we have ChatGPT. Everybody's so excited about it. It has an amazing promise. We still have to work on a little bit, but I think it has an amazing promise, right? This is the level of intelligence we have reached. We now know how to build systems for learning, for understanding, for thinking, and for creativity. Today, we can create images with DALI. We can create music with Jukebox. We can create text with ChatGPT and all of that. Creativity is there, right? So this is the 4 levels of intelligence that we have reached. So therefore, this is an amazing time to understand this field at both philosophy level and practical level. And then the last level of intelligence is consciousness, which is really when a machine will become self-aware. And that's what some of us are worried about. The Elon Musks of the world are really worried about, when are we going to hit this singularity. I hope it will not happen in our lifetime, but that's what a lot of people are worried about, because we have made so much advances so quickly. The regulations are so behind. Nobody knows that, is it the right thing to do or not? And we're just going on and on about it, right? It's all open source. Everybody has access to it. So it's a very powerful tool, and the regulations are far behind. So we don't know whether we are going to redeem humanity with this or destroy humanity with this. We don't know that. This is a very delicate stage that humanity is in. Yeah. All right. So now, if I think about what is learning, right? So it's a very simple, beautiful thing that our brain does. It's called learning. So what do we do? When we see a bunch of squigglies and images like this, our eyes are trying to figure out what we are seeing, and you will immediately say, I'm seeing a letter A. And the reason why we say that is not because we have seen these letters A before. We have never seen these A's before, but still we are able to say that this is a letter A. Why? Because our brain is not a memorization system. It is not a database lookup that I have to remember all possible A's before I can recognize a new A. Our brain is a generalization system. That means it will build a model for everything, and it will keep updating the model throughout the lifetime. So our learning systems, right? So we have a model for everything, millions of things that we have experienced in life, the letters, the words, the people, the places, the foods, for everything, there is a model. What is a biryani? There is a model. What is that aspirin? There is a model. What is COVID? Now we know there is a model in our brain. What is COVID? So the idea is, with a lot of data, we have learned how to build models for everything. The brain has this natural ability. And now what happens when an input comes like this input goes to millions of models in your brain, and one of them says this is an A. Everybody else is silent. This amazing ability of the human brain to manage and maintain millions of models of everything and infer from them all the stuff that is happening. Imagine we are watching movies at 30 frames per second. Our visual system is understanding all of that so quickly, right? It's amazing that we are able to do this, right? So learning is an amazing skill. What is understanding? How do we understand language? Understand what is a pixel? Pixel is just a red pixel. It doesn't mean anything unless it is part of a rose flower in an image, right? Or it is part of a blood drop in a movie. That pixel is just a pixel, right? So what is understanding? So if I look at these sentences and say, look, there are 3 words that are common. Are they the same sentences? Are they similar sentences? But our brain says no. Why? Because the meaning of the word is different. The word right and the word right, suit and the word suit, apple and the word apple. So the meanings are different, and therefore, we say that these are different sentences. Our understanding of a word, which is a content, depends on the context in which it occurs. So understanding is all about part-whole relationship, right? How do you understand letters from words and words from letters? How do you understand a word from sentence and a sentence from a word? How do we go up and down? And this is an amazing ability that the brain has to put everything in context, right? And this is the famous dictum that you shall know a word by the company it keeps. Now we can say you shall know a pixel in an image by a company it keeps. You shall know a frame in a video by the company it keeps, the frames you have watched before and after. You shall know a nucleotide or an amino acid in a protein by the company it keeps. So you see how profound this idea of understanding is. How do we understand something in the context of where it is? That's a profound skill. And now all our deep learning systems are now mastering this art of bringing context and convolution networks and all that to understand everything at multiple levels of abstraction. Yeah. What is thinking? This is a completely different skill, right? So thinking is all about where am I? What is my current state? So let's say this is a math expression you want to simplify. So this is your current state. What is your brain doing now? It's saying, hey, what can I do with this? If I'm at this state, what are my possible next states? So you cannot suddenly say, I can do sine X and sine Y. Why? Because that's not reachable. The math doesn't allow that. So your brain is saying, what are my possible options? And then if I know how to do this many times, learning to think, then my brain will pick one of them and say, this is the right option. And then we go there. Now the state has changed from one expression to the next expression. And now you apply the same logic again. What all can I do now? And out of that, which is the best option? Then what I can do now? Then which is the best action? Then what can I do? Which is the best action? So the idea of thinking is really about exploring all options, picking one, then going forward, exploring all options from the next move, board position, and picking one, right? So this ability we have now mastered in reasoning algorithms and theorem proving algorithms. So now we can think long term, and AI can think long term now. How can you use that potential? So imagine building a career of somebody is a thinking process, right? It's a long-term decision. How do you think about the right advisory? It's a sequence of advisory that will give a good crop, not current advisory. So it's a thinking process. You see, so learning, thinking, and understanding. And creativity, we are all experiencing ChatGPT and everything else, right? So you understand how amazing the times are. AI has now mastered all the 4 skills that you will call intelligence. Yeah. All right. So now let's talk quickly about the different frameworks in AI, because I want to really reach a point where we can talk about why so many frameworks, why do I have to learn so many tools, I want to reach that point, right? So first, let's talk about the variety of tools that we have. So AI is now like a 4-year-old, right? It can create insights from data. It can learn rules from, it doesn't have to encode rules. It can actually learn rules from data. It doesn't have to hear. It can actually understand what you're saying, right? Alexa, Siri, and all of that. It can understand the images. It can understand the videos. It is not just that you take a picture, store it somewhere, send it on WhatsApp. That's not enough. Today, Google Photos can actually search by face every person in your library. So it's able to understand, right? So we are moving from collecting data to deeply understanding data, right? Google today is very different from Google 20 years ago, right? Earlier, it was just using the words as is and fingerprinting them and saying, I'll build an indexing system. But today it understands the web, right? And now imagine it will, in the next few years, it will understand the videos. And now we are able to see that, you can make a query that says, show me all the goals by, Ronaldo against this team in the 2023 World Cup. And it can go and just precisely carve out those pieces of videos and show you, right? That is possible now because understanding of videos, understanding of images is going deeper and deeper. We don't have to encode moves, we can learn strategies. And that's what AlphaGo and Deep Blue can do. They can just play chess or AlphaGo or any game for 5 minutes on the cloud, billions of games, and then just beat the crap out of every grandmaster in that game, right? Because they have learned the art of building strategies very quickly. So AI is now at a very advanced stage. It is 80% accurate on an average everywhere, which is like a 4-year-old. Now we are ready to use it to build products and solutions. And we are seeing a lot of it happening in front of us, right? So what are the core tools? I'll just go through it quickly because you get a sense of, yes, there are many tools. It's a very complex domain. I need to really, take a break from my day-to-day job, really understand this, imbibe this into my thinking, and then come out on the other side as somebody who is empowered with all these tools to really change the world the way the world is expecting AI to change it, right? So clustering is a very powerful tool where we do grouping of similar things together. So this is the clustering of customers in a retail. Now each box is a cluster of, let's say, thousands of customers. And immediately you can see how I can go from broadcast decisions to personalized decisions. So now Xbox can say, hey, I want to send so many coupons to my loyal customers. I already know who are my loyal customers, right? Or GameCube says, hey, I want to acquire PlayStation customers. Can you run a campaign for me, but only on PlayStation customers? Retailer has that power. Manufacturer of products don't have. Retailer owns that data, right? So you can do many, many things with this, right? Another tool that is very commonly used is what we call outlier detection, right? This is very useful in, a lot of hacking is going on. So you can tell that, hey, something is wrong in this sequence of Unix commands. I need to do something. Or you can say that this credit card transaction doesn't look normal. So how do you detect outlier behavior, right? How do you detect money laundering or fraud happening on UPI or in Paytm or Google Pay, right? There's a lot of fraud that happens. They can catch it within 1 or 2 transactions, right? Cybersecurity is a big problem, right? Global threats from terrorism is a big problem, right? All kinds of outlier behavior you can do with this kind of a tool. The next, we talked about interpretation, right? How do you deeply interpret everything, whether it's an image or a video or a PET scan or an X-ray or a time series or a piece of text? And when I say deep interpretation, we are not there yet, but we are getting there, right? So tomorrow's vision systems will be able to tell me what is the approximate age of the girl, what is the breed of the dog, what is the dog doing, what is the type of flooring, what is the brand of the chair, all of that it can tell. The next level of vision, right? Today, sentiment systems are positive, negative, but really if you go deeper, we should be able to say, what is the entity, what aspect of the entity, and therefore what is the sentiment of that aspect of that entity. because we never say things in black and white anymore, right? We like few things, we dislike few things about the same entity in the same tweet. So how do we go deeper into text interpretation, image, video, and all that? How do we predict something in the future? It's a completely different paradigm, right? So the idea is you have historical data, and now you can extract features and you can build models to predict a target event, right? Now, if you have not noticed this, India is going to completely transform healthcare. And there are certain things the government has done, especially the national health stack, right? So if you look at where we are heading in healthcare, and this is a huge opportunity for us to transform healthcare that never has been possible before. So today what is happening is the national health stack, with the ABHA ID, today if you go to a lab environment, you have a different ID. You go to a hospital, you have a different ID. You go to a pharmacy, you have a different ID, right? So you have multiple IDs. Your data as a patient is sitting in multiple silos, right? And it's not connected. So today, if you have to show your last 6 months of blood reports and all the diseases and all the medications, you have to carry a big bundle of papers with you. That is so primitive. Just imagine that for Netflix, we can click a button, watch a movie, but for healthcare, we are still very primitive. We carry a piece of paper, right? A printout from a blood report or a handwritten note by a doctor or an ECG or an X-ray. We still carry physical data, right? So you see the amount of transformation that is possible. So what India is doing now is we are connecting the dots. So we are saying everybody will have an ABHA ID. All the medical institutions are supposed to use that as a primary ID, like Aadhaar card for other things, PAN card for other things, for healthcare, ABHA ID, right? So now what happens? All your data sitting in all the silos can be retrieved in one place with your consent. Consent is important because you are sitting in front of a doctor, you have a certain condition, you have given consent. Now imagine all that data is available to a doctor or to an AI system. Just imagine all that data is available to an AI system who can look at all your past transactions. So imagine these past transactions, right? You don't remember when this happened, when that happened, but the data is there. Now imagine with that data, not only I can build a better diagnosis for you today, but I also can predict what is coming. This has never happened in the history of mankind, that we can predict what kind of diseases might come and you should take care now, right? This is possible now. And because we have historical data, we have longitudinal data. This is called longitudinal data. So today banks can predict churn with this. Manufacturing companies can predict part failure with this. So a lot of things can happen. But imagine the potential of what we can do with this prediction framework in the healthcare world or in the agriculture and other worlds, right? A very powerful paradigm. We need to learn how to do this systematically. We can recognize all kinds of patterns in data now, right? Whether it is sets data, sequence data, image data, we can find patterns, right? And that's something we can do at scale. We can build great recommendation engines. The next class of recommendation engine the world needs is not more movie and product recommendation. It is really more about career recommendation. What courses should I take? What startup should I work for? What college should I go to, right? What is the best career path? Another kind of recommendation in education, right? What is the next best topic to study in math? I'm good with this, not good with this. Tell me what to study next. It's a big problem in personalized education. So we can solve that. Agriculture, a farmer needs an advisory today. What should I do? Can it come based on my future calculations, integrating all the data in one place and recommending? So personalized advisories will become the next generation recommendation engines, which will integrate wide variety of data, balance strategic and tactical goals, and then give you the right actions, right? It's completely amazing the way it can transform the world. Yeah? So when we say recommendation engine and apply songs and music, it is a very, very trivial solved problem. But when you see the full potential of it, you realize, oh, that's what is possible, right? Then we talk about reasoning. Reasoning is another beautiful paradigm. It talks about a sequence of action. So we are now applying that in many places, right? Reinforcement learning is another framework which says, here is your current state, here are your feasible actions, here are your recommended actions based on what is possible. If you have exploited your world enough, then take this action. If you have not, then explore and collect more data, make some more mistakes, learn more about alternatives, then take next action. Then the domain knowledge gives you the reward and punishment, the environment gives you reward and punishment, and you go to next state. This is a very powerful framework. There are classes just on this topic. There's a whole course on reinforcement learning, which says, how do we learn this, right? This is going to be the next big, primary thing. Today we build, other type of models. Reinforcement learning is yet to become a primary tool in AI. Okay? Then deep learning, we all know, we all understand. So whenever the raw data is at a very low level of abstraction, and the outcome is at a very high level of abstraction, right? Pixels to actions in a video, then we need deep learning. So we all understand that. So these are beautiful paradigms that have emerged in the last 50 years. And now we are wondering, this is what it takes to be a full stack data scientist, which is to know all the tools, to know the connections between them, and then to say, how do I apply this systematically in every vertical, on every type of data? So that is the next journey, right? So now I'll talk about how do we use these tools to solve business problems, right? So let me give you a workflow of AI, right? How do you systematically apply AI? It's not just let me download some data, engineer some feature, build a model, get an accuracy, go to Kaggle competition, get some ranking, and I'm done. It is not that. That is a warm-up exercise. We need to know all this, but we need to now raise our bar to say, I have to build smart cities. I have to uplift agriculture for the country. How will I think about AI as a workflow, not as a model that I build, which anybody can build? So I'm predicting that in the next 5 years, what we think data science skills are will be taught to 12th graders. Every 12th grader will know how to build deep learning models. That is coming. So what we think data science today and something great is going to be taught in schools like we know how to teach math and physics. It will be a common thing. What are we going to do? We are going to go to the next level, right? So we have to start thinking about AI workflows, AI architectures, right? So the idea is, imagine you monitor everything. So in your healthcare world, we monitor all your health. In the world of agriculture, we monitor it from all aspects. In the world of telecom, we monitor how good the call quality are, where the call drops are high, all of that, right? So how do we monitor everything? So that is the sensor thing. Then comes, how do we discover what needs attention? So I don't need to know what is the total sales of this product in this market. I don't need to see the dashboards. The right dashboard is what needs attention. Tell me that, because that's what needs attention, right? Everything else is normal. I don't need to see the same thing over and over again. I just need to bubble up what needs attention. We are building complex systems. So a cell tower is down somewhere. Suddenly a customer is very unhappy, or suddenly, the rain is coming, that needs attention, or whatever, right? There's a big spike in COVID somewhere. Tell me what needs attention is more important than tell me what's going on, right? So how do you discover what needs attention? Third, why is it happening? Tell me the root cause. Root cause analysis is going to become a very important skill set. Automated root cause analysis through a deep layer of causality is a very important skill set, right? So that will become useful. Now imagine automating everything. Then synthesize the right action. So we know that this is wrong. We know why it is happening. Now we synthesize an action. And once we synthesize an action, we execute the action. And we say, okay, you are telling me that this area, there is not enough cell coverage. So now the operations team should know that we need to install a new tower here. So how do you execute the action? It could be a physical action or a digital action. How do you execute? And once you execute it, how do you measure impact? Did you actually solve the customer problem? Did you actually improve your operations efficiency, right? Did you actually improve your profitability? How do you measure impact? And once you're able to measure impact, how do you learn from that feedback? Maybe I did not discover the right alerts. Maybe I did not do the root cause properly. Maybe I did not synthesize the action correctly. Maybe I did not execute it properly, right? So how do you learn from that feedback? This cycle is what we call a exception workflow in AI, right? How do you institutionalize this cycle in every vertical? Every vertical can use this generic cycle, right? Whether it's a hospital running an ER system, or whether it's a COVID center for the country, or whether it's an agriculture ministry of India, whether it is a taxation system, every system can use a workflow like this. Can we think like this? That is what the goal, right? This is what I mean by the art of formulation. Building models is fine, but we need to now we need to prepare for the next 15 years, right? So this is what, you can think of a very simple way to describe AI, right? Demystifying AI. This is a simple architecture of what is intelligence, right? So all intelligent systems, amoeba to lizard to monkey to humans to robotics to chatbot, right? Every intelligent system does the same thing. It's a very universal architecture. So there is a stimulus that is coming in. So whether it's a query on a chatbot or a search engine, whether it's a blood report and whatever symptoms and reports to a doctor, all this is stimulus, right? All your data you are collecting. The first act of creativity in AI is converting your stimulus data to a state vector and saying, is it a happy customer? Is he a price sensitive customer? Is he a loyal customer? Is he a valuable customer? Is he a fraud customer? So how do you convert lots and lots of transaction data to 5 very important semantic numbers? That is called stimulus to state thinking. So really, somebody quoted me saying that really data science is not about data thinking. It's about state thinking, right? So if you think about how banks give loan, they give you loan based on your CIBIL score. So CIBIL score is your credit state, right? And they combine that with your capacity score, which is based on your total income. Then they combine it with your discipline score, which says how many times you are missing EMIs on your previous loans. Are you disciplined financially? Now, these 3 numbers give me your overall financial state. Now, can I use that to do the next thing? How about education? Now, imagine in education, if you could collect stimulus data that say which student is taking more time to solve what problem, more hint, making some mistakes. Can I take all that stimulus data and come up with the state of learning of a student? And if you can do that, so now stimulus to state thinking we understand. And then from state to actions. How do we now say you are in this state, your heart risk score is high, your psychological health is okay, and your kidney is working fine. What is now the action, right? So again, depending on the state, what is the action? This student has this learning profile. What should he learn next? This crop is showing, some kind of stress because of water stress. What is the action I should recommend? You see, state to action conversion. And once you do that, then you synthesize the response. So really, what is an AI system? It's a stimulus to response system. But the most important aspect of that is the feedback loop, right? And that's what we have mastered in the last 20 years. We have mastered how to collect feedback and how to use the feedback to learn how to improve our system of analysis, how to improve our system of reasoning, and our system of synthesis. And if we can do that continuously, this is exactly what babies do till they become adults, right? This is what Google has done in the last 20 years. Every intelligent system is going through this loop. That is how simple AI is. Now, what is the role of different modeling techniques in all this? So if you think about the modeling techniques that we talked about, right? So we talk about NLP, speech, vision, customer segmentation, customer profiling, demand forecasting. What is all this? All this is really converting stimulus data to state of something, right? What are you trying to say? Query intent, query understanding, speech understanding. So stimulus is audio, understanding, right? Customer data, understanding of customer. You like certain movies, you like certain brands, understanding, right? Demand forecasting, understanding of what is coming. state, future state. So this is all one part of AI. And the second part of AI is state to actions. How do I convert that understanding of state into actions? Next best action. What you should study next. What is the best advisory at this in this context? How should I optimize something? Right? How do I apply business logic? So all that is actions. So we understand this one slide captures the essence of two things. One is the notion that AI is a stimulus response learning system. All the techniques that we learn in AI either fall under stimulus to state techniques or state to action techniques, right? And AI is a continuous learning loop. It is not like we have deployed a software, it is done. AI is a continuous learning loop. Right? Okay. Now, one of the reasons why Googles of the world are willing to open source their TensorFlows and their whatever, right? Azure MLs and all that. Why are these companies okay to do that? Why are Googles of the world not worried about somebody else building a search engine with the same technology? And the reason is they have understood something very, very fundamental in the last 20 years, which is AI is not just about the data, the modeling tools, and all of that. It's really about the implicit feedback. So the Googles of the world are, like I said earlier, we are not just building products, we are building sensors. The feedback data that they receive is far more valuable for them than the free service that they're giving you, right? So there's no free lunch. And the data that they collect over time is what is responsible for improving their quality of service, right? So Google wanted to make sure its click data is never going to somewhere else. So they build their own browser, their own Android operating system, now their own cell phones. Why? Because they want to make sure that their click data is not going somewhere else, because that is their bread and butter. They have mastered the art of using click data as a feedback loop to continuously improve their search engine. They have completely automated the process that even if nobody goes to work on for 3 months at Google, search engine will continue to improve automatically. That is how amazing that system is, right? You don't need humans anymore to improve that. It will continue to improve. Similarly, if you think about YouTube and Netflix, it's not about the click is a feedback data. It's a percentage watch time. So this kind of innovation that happened, what is feedback? How do I collect the right feedback? How do I do it implicitly, not an extra button to be pressed, right? Amazon knows what you buy, when you buy, what you search. Do you buy at full price? Do you add to wish list? Do you return the product? Do you read a review, write a review? So there are 20 relationships between a customer and a product. That is how rich the relationship building is. Recommendation engine, everybody can build. But building this kind of feedback infrastructure is what the secret sauce is. So we're going to learn amazing things about real world applications and nuances of how to apply AI and what are the holes and gaps in AI deployments and all of that. So feedback loop thinking is very important. So now when I go to companies of different verticals, I ask the same 5 questions, right? The first question, so this is a refinery world, for example. The first question is, what are your metrics? What are you trying to optimize? And a business leader should be able to clearly articulate what are his business goals, right? So in Ola, Uber world, they should be able to say, I want to make sure my drivers are earning well. I want to make sure my customers are getting cabs that they need. I want to make sure that I am profitable as a business, right? I want to make sure that the quality of rides is improving. So they should be able to articulate their metrics very well. That is where the journey starts, right? So everywhere, when I worked at different companies, they had big sheets of paper talking about what are the KPIs that they are tracking, right? So how do you think about metrics? So that's a metric thinking, which is important. Every vertical has their own metrics. So what are the metrics here? How do I minimize the unscheduled shutdowns, right? Every minute my refinery is not working, I'm losing 1 crore rupees. So how do I minimize my unscheduled shutdowns? How do I maximize the efficiency of the plant, right? What is the domain knowledge I have? right? I know all the chemistry, the chemical engineering, the petroleum engineering, the thermodynamics of all my equipments. It's a lot of domain knowledge. Good news is data scientists need to learn the domain knowledge at a certain level. We don't have to become PhDs in chemical engineering or retail. We just have to know it at the right level. And because AI is a horizontal skill, at least I was blessed with working in multiple verticals, right? From search engines to Ola Uber to refineries. So I see the same pattern. And that's what the pattern I'm sharing with you. This is the kind of insights we share when we do this course, right? And so what is your domain knowledge? What is your stimulus data? What data are you collecting on a daily basis? So how do you think about stimulus data? And how do you convert that stimulus data into state of health of your plant, state of efficiency of your plant, state of productivity of your plant, right? How do you convert that? How do you convert that to the lifetime of the unit, every unit, and say this unit is going to fail in 3 months, in 1 year, you should order this now, you should order this tomorrow, right? And then how do you run the plant, right? How much temperature, pressure, whatever, how do you control everything based on the state of the plant? So this is a journey that every vertical can take, right? Now let's talk about retail, for example. What does it mean? What are the metrics, right? What are the store metrics, customer metrics, product metrics? How do you think about metrics holistically? How about the domain knowledge? So we know that certain products are sold more and less in certain times, right? That kind of domain knowledge. We know certain products go with certain other products, right? What is the stimulus data you're collecting all the time, right? All your point of sale, all the coupons and campaigns you have run, and more importantly, the clicks and conversions of those campaigns in the past. That is your stimulus data. Then how do you define state of a store? How do you define state of a product? How do you define state of a customer, right? For example, what are the brand preferences of a customer? You can define that from the data. What are the price sensitivity for different categories of products for a customer? So he doesn't buy washing machines and certain products very easily unless they are on sale, but he is willing to pay a premium for a next mobile phone. So how do you understand customer from their data, right? And then how do you create a cross-sell, upsell, store layout, supply chain, warehouse, all the decisions that you need to make in a retail vertical? See how holistically you can think about AI. AI is not about building a model and deploying it. It's about converting a complete vertical into this process, into this systematic machinery. Yeah. And that's what we learned here. How about agriculture? Again, what are the metrics? So now we know soil has to be better and improving. Yield has to be high. Cost of agriculture has to go down. Chemical usage has to be minimized. So we know many, many metrics now. Every vertical is a multi-metric optimization problem, right? You cannot have everything. What is the domain knowledge in agriculture? Agriculture has probably the largest domain knowledge that we ever have. Books in agriculture are the biggest, not medical science. There's so much domain knowledge. The problem is that knowledge is today meant for human agricultural scientists to learn or farmers to learn. It was never meant for AI to consume. So now we are digitizing that knowledge into knowledge graphs and saying which crop needs what kind of sodium, potassium, at what stage, what is the best soil, what is the best climate, what is the optimal moisture. All this knowledge has to be coded somewhere so that AI can do reasoning on top of it. So data science is not just about downloading and building high accuracy model. It's about thinking about all aspects of a solution, right? So how do we then think about stimulus data? So if you think very carefully what we have done in the world of Googles and Amazons, we have been very strong in collecting feedback data, right? We know the art of implicit feedback data. Now think about agriculture. Why has agriculture not picked up as an AI system? Because we have not collected data the way we have collected it in other domains. This is the problem with the physical systems. Physical systems don't collect digital data very easily. A farmer may write down in his diary, today I watered my plant this much. Tomorrow I will put some fertilizer, right? He may collect logs, but they are physical in nature, right? How about soil IoT? Now soil IoT can collect, so moisture content and all that every 6 hours. So that's an amazing thing. Now we make agriculture data rich, right? The farmer can take a picture every day of his crops and send it. Satellites can integrate that with the satellite picture. Now you start to see how agriculture get transformed and become a data rich environment, the way Google's and Netflix's have become data rich environments. And then the magic will happen, right? Now you can say what is the state of the soil, state of the crop, state of the water table below the crops, all of that you can figure out, right? And based on that, you can generate a daily advisory to a farmer, right? And that's a process, same process that we apply in refinery, we can apply here. How do you learn AI from this point of view, right? That is possible. How about agriculture? We know what are the metrics in agriculture, right? Today, one of the worst things we have done is followed the same old British education system even today. We have produced only 10 Nobel laureates in the last 100 years for a country of a billion population. Just imagine how bad our education system is. We are all part of that, but we don't see, we are not shocked by this idea, by this one statistic, that we have only 10 Nobel laureates in the last 100 years for a country whose average size is a billion people. Something is wrong. It should shake us, right? So we have a huge opportunity to say, how do we transform education, right? Domain knowledge in education is a lot, right? We know a lot about what should you teach after what should you teach after what. Now we are not collecting stimulus data. If we stay with physical homeworks in notebooks, we will never create digital platforms for collecting digital data, right? We need that. Once we have that, once we know which student is precisely making what errors and what problems at what step, we will know their student profile of learning. We will be able to tell exactly what student 1 of class 8 is missing and where another student is ahead. We can actually profile them very, very deeply and create the right personalization and say, you need to learn this today, you need to learn that today, because that's what I'm recommending based on an optimal journey for you, which is very different from another optimal journey for another child, right? It's a shame that we have personalized the hell out of Netflixes and Twitters and Facebooks, but we have not done this in education. This needs to change, right? So with that fire, we have to work on AI, not because we need a new job. We have to transform all these verticals. Yeah. So let me conclude now. So really, we looked at AI from many angles, right? There are a lot of tools. There is an overarching way of seeing AI. There is a philosophy of it. How do I now think about practically deploying AI in any vertical, right? So what we do, we work backward from decisions, not forward from data. One of the biggest mistakes data scientists do is they ask the wrong question first. They say, show me the data first. It's a wrong question, right? If you are a chef in a restaurant, you don't go and look at what tomato and potato you have in your pantry. That's not what you start with. You start with what is the menu that I'm going to deliver? What is the customer asking? You start with that and work backwards, right? So you work backwards from decisions. So you say, what decisions are my businesses making in every vertical? How are we making it today? Is it manual? Is it rule-based? Is it some intuition that the boss said do this? Or is it really data-driven, right? How are we making those decisions? And what data are we using to make those decisions, right? So on one side, we are becoming data rich, but we are not using that to make our decisions. That's a weird thing. So we need to connect. So I tell my students, right, data science is really like a shadi.com, right? It's a matchmaking between the data you collect on one side and the decisions you make on the other side. How do you do a matching between the two? And that's where we come in to help improve our decision making, right? And you saw the journey. How do you know that it was a good decision, right? What data did I use to measure my decision? Feedback loop, right? How do we think about that? And how do we close loop this? AI is not a one-time exercise. For me, building a first model is not important. I can have very wrong first model. For me, building the nth model, given the n plus minus first model, is more important. Induction, right? What did I learn from the previous model? What mistakes am I still doing? What data am I still collecting? Then am I able to automatically engineer the next right features and improve the model again? Am I able to close the loop in learning? That is what a truly intelligent system does. It's not a data to decision one pass. It's a feedback loop, right? So hopefully this gave you some new insights about what is AI, what is the promise of AI, and what kind of a next generation skill sets we have to learn to get there. Yeah. So we are all very excited at Geo Institute to impart this level of teaching and understanding. We have a lot of industry experts who come in and talk about how they are using AI. We have a lot of very good faculty who talks about the deep tools, algorithms, and theoretical foundations. And we have people who teach us different tools, how to do snowflakes, how to do, Power BI, how to use TensorFlow and all that. So we are learning a lot of hands-on tools while we are also learning industrial applications, theoretical foundations, and it gives us a very holistic feel for how to think about AI. Yeah. So I'll stop now. I'll take some questions and then we can go back to other things. Yeah. Thank you.
Thank you so much, sir. It was quite an insightful session, and I'm sure that our audience loved every single minute of the session. And there are certain questions for us today. So first question is, how is Geo Institute's Artificial Intelligence and Data Science program unique?
Yes. So like I said, we built this program based on what we see as the last 20 years of AI and the next 20 years of AI, right? So we have made sure that you get everything. You get core basic foundation. So some of us may have forgotten how to do programming well. We need to brush that. Some of us may have forgotten how to do probability and statistics and optimization. We will brush that. So we have one layer of foundation courses. We don't assume that you have all that knowledge. We build that up in the first quarter. Then we do the core courses. So we want to make sure that you understand AI at a breadth level. You understand all aspects of AI, whether it is speech, vision, NLP, reinforcement learning, machine learning, deep learning, AI. We understand all aspects of AI. So it's a very horizontal, the next 2 quarters. And then we do the depth one, which says, okay, now that you know the entire spectrum, you can pick and choose and say, I want to go deep into deep learning for vision, or deep into a particular domain, and say, I want to work in agriculture, what can I do? So you can either go deep into a domain, or you can go deep into a technology, right? Really, it's all about either picking this or that and then combining the two. So that is one thing. We have designed a program to be very holistic along these 3 dimensions. The foundation courses, the core courses, the advanced electives is one aspect. The second aspect is we have brought some of the best faculties from across the world to teach those courses, right? So because those faculties are the ones who actually invented some of these ideas, they are teaching you. We're not just getting somebody who knows, who has read a book and he's teaching you. That you all can do better, right? The person who is so passionate about that algorithm, that set of ideas, he's teaching you and communicating his thought process. So we are hoping that we will pick up some of that, right? First principle thinking, how to create new machine learning models from scratch, how to think about innovating in AI. Then we are building industry experts who have really spent years together in an industry, right? And have thought about AI, how they have to apply this in that industry. They will come and teach us what does it mean to institutionalize AI in a retail domain or a telecom domain or a healthcare domain and all, right? So we have very nice industry AI for X series of talks. X could be anything, right? AI for healthcare, AI for
could use uh, I could use GPT. Just give me a second. Yeah, so I'll again read it out for you. So how can we build Chat GPT or Mid Journey kind of tool here in India? What is required from skills, times, and resource perspective? So you are on mute.
Sorry. So yeah, I think Chat GPT itself is a very, very complex model. It was built on almost trillions of pieces of information. Building such a system from scratch, it requires a lot of resources and all. But now there's a lot of innovation that can happen on top of it, right? So now there are almost, every day there is a new startup doing something with Chat GPT today. It is catching fire. Innovation at the use case level, right? So ChatGPT people are using for various things. So if you start looking at how to use it for code generation or for writing a news article or writing a job description or a resume or whatever, right? So, or a prescription. So there are a lot of use cases that will come up, and that is the innovation that will happen. ChatGPT is a very powerful tool, like mathematics, like physics, and all that, but it is a creativity too. So now you can do amazing things with that. Yeah.
Yes, sir.
But the only thing I will say is that it is still very English centric, right? So if you want to do something India centric, one of the innovations could be to use it in English, but translate it into any other language and do that. Education could be a very, very big use case. The only problem is the outcome of ChatGPT is grammatically very nice and correct, but knowledge-wise, it may not be. So it needs to be correct and pristine from a grammar point of view. So we need to look at that aspect. And once they master that skill also, then we are there, right? But yeah, it is a very powerful tool.
Thank you, sir. So there's another question on job opportunities. So what kind of job opportunities one can expect in the field of AI after completion of this program?
Yes. So, it's a function of multiple things. One is your temperament, right? Some of you will have a very data-centric temperament. You love data. You want to do data engineering as your career choice, right? So you want to work with large-scale data, all types of databases, do high-scale data computes, build data pipelines, right? So some of you may like that. So data engineering is a very important skill, and that is one area, right? Some of you are domain people. You understand domains very well. And now you are combining domain with data. So you want to run certain hypothesis testing, try this, try that with data. So you can use that skill set, combining domain knowledge, extra domain knowledge with some data skills to be a data analyst as another skill, right? But the real skill role that we are preparing you for is a data scientist role, which is how do you, like I said, right? How do you take a business problem, convert that into a data science architecture, build good models, and deploy them, right? So you can be a data scientist. You can also be an ML ops engineer. So if you like to work at the fag end of how to deploy models, how to scale them, how to make sure they're secure, how to automate the process of deployment. If you love that kind of work, how to do deployment of models in the edge, then ML ops, AI ops, and data ops, these are also very important skill sets now that are missing in the industry. So you can have that. Or you can actually, if you are a very senior person and you look at things top down, you can be an AI architect also, who can look at putting the whole architecture of a vertical together, right? So these are some of the roles you can think of, all the way from data analyst, ML ops, data engineer, data scientist, AI architect. And it all depends on what you want to do, which part of AI you want to do. And obviously, as the course will progress, you will discover what kind of a person you are, right? And you can also be a researcher in data science, right? A true data scientist who is building a new machine learning technique or deep learning technique. So you can also do that. So the capstone project we are giving, last 2 quarters of capstone project is a 6-month capstone project. It's a 6-credit course. One course is 3 credit. Capstone project is 2 courses equivalent. This is a huge opportunity for you to go very deep, apply whatever you have learned, follow your passion, either create a new solution to a problem, advance the state of the art, or build an amazing model and win a Kankel competition. It's up to you. And when I look at the kind of capstone projects people are doing, they're just all over the place. We are doing something in the legal domain, in the healthcare domain, in the agriculture domain, and I can start to see the glimpses of our dream, starting to fruitify, that people are now passionate about solving interesting problems. So on the job front, right? See, jobs are temporary, right? Today you have it, tomorrow you have something else. But what is your passion? Why do you want to be a data scientist? If the answer is, okay, I am a software engineer, I'm sick of it, I want to do this, or everybody's talking about it, therefore I want to do it, then don't come to Geo Institute. Your answer has to be, hey, I'm passionate about this vertical. I'm passionate about this technology. I'm very interested in how vision systems work. I want to understand that, advance the state of the art. I want to solve a critical problem. I want to transform education, healthcare, smart city, retail, whatever you want to do. You should have that passion before you join a data science course. Otherwise, it's just another course like Coursera, right? We're looking for passionate people who feel that AI skill set is the only thing that is lacking between where they are and what they want to achieve in life. And if they had this skill, they could really not only, transforming your own career path will automatically happen. That is not even, that will you get a better salary? Will you change the direction of your job? That will automatically happen. But the real outcome is that you will be able to contribute to the future of humanity in one little way. Because to do that, you need to learn this technology. Very powerful, right?
Thank you so much, sir. So there is another question. What are prerequisite skills or knowledge one needs to apply or consider to join the course?
Yeah, so I think, there are 3-4 skills we talked about, right? And, if you have good domain knowledge in a certain domain, which generally everyone has, then that's a very good skill to have. A lot of people say that, oh, I'm a chemical engineer, I'm a mechanical engineer, I've been in retail for a while, I've been an insurance guy, I'm a doctor. Am I qualified for this? Yes, you are, because you have domain knowledge. Domain knowledge is a very big asset, right? The second skill is you should be mathematically savvy, because to explain and understand these algorithms, it is necessary for us to do it in a language of math, because these are very complex ideas. You will not be able to understand them unless you are comfortable with the language of math. So if you have done good in math, 12th grade, you've done some math in your college and engineering, you're comfortable with math. Some of us are not comfortable with math. And even if you're not good at math right now because you forgot, but you can catch up and you can still say, no, I can become comfortable with math, basic math, right? We're not talking about some very fancy stuff, probabilities, statistics, little bit of optimization, little bit of calculus, little bit of matrices and vectors, right? So we are going to cover all that in the first quarter also, but we are looking for some, significant this. And the third is some level of programming skill, some level. You should not come in and say, I've never done any programming. I don't know what's a for loop. I don't know what's an if statement. I don't know how to write a single program, hello world in any language. I want to do data science. Then you need to brush up between now and when you join. You need to pick up Python. You need to pick up your favorite programming language. And if you listen to Steve Jobs, he said somewhere that every kid in the world should know how to program. It has absolutely nothing to do with the fact that you want to be a software engineer. Learning to program is actually helping you learning to think. People who can program well can think well. And you will see this. When you start programming, you will start to think more logically. Your IQ level goes up. Just for that reason alone, one should program. And we are working with schools now across India to create courses on programming, which are going to, and kids are saying, no, we don't want to be a software engineer or computer scientist. We want to be something else. Even if you want to be a doctor or a social worker or a chef, knowing how to program will help you become a better thinker. So for that reason, at least you should know some basic programming. And once you do it, you will understand what I'm saying. Yeah. So some coding skills, not necessarily Python, anything, but you will pick up Python because you have some coding skills, some math, some domain knowledge. If you have these three things and a lot of passion to change the world, then you are welcome to the institute. Yeah.
Thank you, sir. This covers a lot of questions that were asked related to the background.
Yes.
So the last question for today is that according to you, what all areas will see drastic transition in coming years because of the application of AI?
Yes. So like I said earlier, right? So there are social sectors that are going to be now transformed. If you look at the National AI Strategy of India, if you read those first papers that came out a few years ago, they are all about social transformation, right? How can you do better agriculture, better healthcare, better education? How do you make cities safer? How do you, make transportation safer? How do you, so these kind of things which will raise the quality of life for all citizens, that is where AI has to be applied. That's the next logical thing. We have only practiced how to do it, like a net practice in the last 20 years. We can scale, we can collect data, we can apply different techniques. We have practiced how to do it. Now we really have to do it. We have not done it yet. So what Sundar Pichai was saying is an unfulfilled promise of AI, that it will transform human race and all that. It will, but we have to start applying it. So a lot of those social sectors will get completely transformed. And I've been giving examples on that, right? Women's safety, right? Nutrition, malnutrition, right? Pandemic readiness. There are a lot of sectors which need help. And today they don't have help. So that is where AI will really push the envelope. Yeah.
All right. So there's another question. AI, we try to recreate, mimic human brain, but at the end of the day, all we understand 0, 1. So can we really reach there?
Yeah, with 0, 1, see what we have done to the human civilization. All we understand is 0, 1, and still we are able to have this conversation, right? We understand 0 and 1, and we watch Netflix, or we are going to the Mars just because we understand 0, 1. 0, 1 is the foundation. Neurons in the brain only understand 0, 1. It's not what a single neuron does. It's not what a single brick does in a palace. It's the putting it all together that creates the magic, right? With that 0, 1, we have created ChatGPT. With that same 0, 1, we are now going to run, autonomous vehicles. So 0, 1 is not a trivial thing. It's a very powerful thing. We have created the whole VLSI industry around 0 and 1, right? Transistors, now we are going beyond 0, 1, by the way, right? In quantum world is not 0, 1. It's something else, right? So qubits and all that. So you can see that it's not the little parts that matter, right? Every cell in your body is by itself looking very trivial. But when you put them together in a certain way, it creates you, the human body. That is what we should work backwards from, right? So if you put all that, your billion neurons are creating this human civilization. That doesn't trivialize the importance of a neuron. It's just that we need to learn the art of putting it all together. Integration. And if we can integrate all the AI services together to create these solutions for the world, that is what the world is looking for, right? And that is where your creativity will shine.
That was quite insightful, sir. Thank you so much. So thank you for joining today's session. For more updates, we request you all to visit our website, that is www.geoinstitute.edu.in. So if you have any more questions related to AI, we request you to email it to us on admissions@geoinstitute.edu.in, and we'll surely take it up with Sailesh sir. Also, you can get in touch with us on 1800-889-1100. That's our admissions helpline number. And as you all know that we have already launched our admissions for all the 4 programs on 15th of December. And we invite you all to the campus to visit us and seek more information, meet faculty, meet current students, and know more about the programs. And thank you all for joining us today. And thank you, Sailesh sir, for taking out time today for the session. It was really, really insightful.
Thank you. Thank you all. Have a great evening. Hopefully I'll see you sometimes in the institute. Yeah. Bye.
Thank you, sir. Thank you, everyone.